So in this video, I'll be going over rectangles, squares, trapezoids. I guess in the previous video, I jumped ahead when I was saying rectangles and squares are special cases of parallelograms. So this book does a weird way of organizing these topics, but that's okay. We're here mainly for the practice problems, honestly. But let's go over the things that you probably need to know according to this book. So let me share that on my phone again real quick. Give me 1 second. Okay. I apologize for the glare. Okay, we'll be more toward the bottom of the screen, but that's fine. As I said in the previous video, a rectangle is a special case of parallelograms. All the angles are congruent, which has to mean that they're right angles, okay? And then another special property of rectangles is that the halves of each of the diagonals are all congruent, okay? Or I should just say that the diagonals are congruent, and then remember, in parallelograms, the diagonals bisect each other, so all the halves are congruent, okay? Now, square, I was saying, is both a rectangle and a rhombus. The sides are all congruent, and the angles are all congruent, okay? And then all the other properties for rectangles and rhomboids and parallelograms hold on squares. A trapezoid only has one pair of parallel sides. So like this one, the top and the bottom parallel. These two clearly are not parallel, right? I don't think this is too important. The mid segment, by the name mid, so it's in the middle, right in the middle of the two non-parallel sides. And by the name again, middle is right in between. Okay? So the length of this mid segment is the average of the two parallel sides. Okay? I don't think this is too important. I've never seen a problem use that. But this book thinks you should know it, so we went over it, okay? And I don't think this is too important as well, but an isosceles trapezoid is when the two non-parallel sides are congruent. And then as a result, the two angles here are congruent, and these two angles here are congruent as well. Okay, this is the more important stuff. Area of a rectangle, area of a square, you can use the exact same formula for the area of a parallelogram, base times height. You don't have to memorize 3 different formulas. This one's the same. But because for a square, this is the base, this is the height. They're the same, so you can remember as side square. But if you don't want to memorize as many things, just remember square is also base times height. Same formula. For a trapezoid, what stuck in my head when I was taught this by my geometry teacher, the area of a trapezoid is the average of the bases times the height. So half times height times base 1, base 2. It's hard to remember. Instead, that's how my geometry teacher ingrained it in my head. Average of the bases, so b1 plus b2 over 2. That's the average of the bases times the height. That's easier to remember. Okay. Now let's go through the problems now. Number 1. In square ABCD above, the length of diagonal AC is 5 root 2. What's the area of the square? Okay? So, we can use properties of the special triangles. In this case, the 45, 45, 90 triangle. Okay? So this length is 5 root 2. What's this length? It would be 5. This is 5 as well, because these two are congruent, okay? What's the area of the square? Base times height, 5 times 5, 25. Easy. In the figure above, ABCD is a rectangle. What is the length of AE? Okay, so we can get the full length of AC by the Pythagorean theorem. So AC is equal to square root of 12 squared plus 9 squared, which is square root of 144 plus 81, which is square root of 225, which is 15. Okay? AC is 15. Remember, in rectangles, the diagonals are congruent. And then in parallelograms in general, the diagonals bisect each other. So AE is half of 15. So AE is 15 over 2, or 7.5. Okay? Now, what's the area of triangle CED? Where's CED? CED. Technically, we can use this triangle as well if we really wanted to. But if this is 12, or this is 9 as well, okay? And we found this to be 7.5, right? And this is also 7.5, okay? We want the area of this triangle, so we need the height. We can do that. Let's draw another triangle here. So, when we draw the height, because these two are congruent, remember there's that property for isosceles triangles. If you bisect this, so bisect this, you also bisect this angle. So this was 9, so this is 4.5 over here. This is still 7.5, right? So now we can get the height of this triangle, h. h is square root of 7.5 squared minus 4.5 squared. Can we do this by hand? 7.5 was 15 over 2 squared minus 9 over 2 squared. Okay, so this is, trying not to use a calculator, it's 225 minus 81. We just did that, did we not? 225 minus 81, that should be 144. So 144 over 4. So this is square root 12 over square root 4. Oh, sorry, square root 144 over square root 4. So that's 12 over 2, which is 6. So the height is 6. Now we need the area of the triangle, which is half the base, which is 9. The base is 9. The height is 6. So that's 54 over 2. And that is 27. Let me check that's the answer. Yep. Okay, so again, you can see how a previous topic came in. You need to know all those previous topics to solve some of these problems. Geometry gets complex in that it combines a lot of different concepts and rules. Okay, what is the area of the trapezoid PQRS above? How do we find area of the trapezoid? Average of the bases times the height. Do we know the height of this? We can get it. So we draw the height. So this length is 3. This length is 10. So maybe, okay. Actually, if this is a 30 degree, then this is the 60 degree here. So this is a 30, 60, 90 triangle. Okay? I didn't even realize that. See, this is why I'm doing these live, so you can see how I see things and think through things. If this hypotenuse is 8, then this height has to be 4. Okay, now we got the height. So average of the bases, which is 10 plus 3 over 2, times the height, which is 4. This is the area. So let's simplify. That's 2 times 13, which is 26. Let me check this answer. Yep. So answer is C. Okay, last one, area of this trapezoid. Okay, this is a weird looking trapezoid, but we can tell that these two are the parallel lines. Okay, now, so what are we missing? We know this base, length of this base, we don't know this, and we don't know the height. We can get this height though, again, Pythagorean theorem. 225 minus 81, I feel like they keep using the same numbers, so this should be a 12 over here, okay? And then by Pythagorean theorem again, we can get this over here. So this one would be 13 squared, that's 169 minus 144. So what is that? That is 25, which is 5, okay? Whoops, getting cut off. Can I zoom out a bit? There we go. This is 5. So now we can get the area. Area is average of the bases, so 9 plus 5 over 2 times the height, which is 12. So this is 6 times 14, which is 60 plus 24, which is 84. that right? Yep, that's the answer. Okay, so you need a Pythagorean theorem a lot in this problem. Not too bad. All right, that's it for this problem set. Hopefully, this is good practice to reinforce those concepts and to review them as well if you've forgotten about them. Okay, so as always, please like and subscribe to if this video was helpful for you in any way, and please look out for the next video, which is on regular polygons. So hopefully see you there. Bye.